What was the USB card of death and how many people died?
I'm in Dave's garage. Whoa.
You once got a death threat over Xcopy, I recall.
So should I further the conspiracy or should I debunk the conspiracy? I could try either way.
You know, I once walked in and I was holding my stuffed orca and he had his stuffed orca and we met in the hallway by mistakes.
I'm not that kind of person.
I hit that in grade 9. And I had a massive pile of cables.
Yeah.
I've got no buffer. I've got nothing
I
in the
got
queue.
nothing. Like
It's all going live tonight. Hey, I'm Dave. Welcome to my shop. I'm Dave Plummer, a retired software engineer from Microsoft going back to the MS-DOS and Windows 95 days. Today, I have the privilege and pleasure of interviewing Raymond Chen, who actually started at Microsoft back in the early 90s along with me, but who has remained there until today, some 30 years later. He's been working primarily on the Windows user interface for 3 decades and knows as much or more about its internals than practically anyone else I can think of. Back in the day, when I had a problem to solve, if I got stuck, it was Raymond that I'd go to see. Raymond has a great book on Windows development, a mix of stories and practical advice. It's called The Old New Thing, and I highly recommend it, so I'll put a link to it in the video description. With that introduction out of the way, let's jump right in and have a chat with Raymond. Behind you there on the shelf is a boxed copy of Windows 95 with stripes. With stripes.
Yes, that makes
commemorative.
it special. Yes, if you look at the box, it says special edition, I believe.
I've never taken the shrink wrap off, so I assume there is magical contents inside. But
Yes, in fact, there is nothing magical about that box at all. The only thing special about that box is the box. The product inside is just a standard retail copy of Windows 95. They just put it in a special box. So the Windows 95 Special Edition box is special for the box.
I thought the racing stripes would make it go faster, but no. The Windows Pinball has turned into something of a conspiracy theory with people with videos out there promoting the idea that perhaps they suppressed the 64-bit versions or they were hidden from the world. What was the deal with 64-bit Pinball and why did it not ship? And why did Pinball get removed from the product ultimately?
Yeah, Pinball, the great pinball conspiracy. So should I further the conspiracy or should I debunk the conspiracy? I could try either way.
We'll record both. How's that?
I'm being recorded. This is going to go up on YouTube. I could just decide to go rogue and go full conspiracy. And then everybody's going to say, "Oh my goodness. It's actually a conspiracy. I saw it on YouTube. Here's my chance to spread disinformation."
You could go that way?
But I'm not going to.
Okay.
I thought about it though. See, this is what happens. I come here and then I get crazy ideas. And I'm like, I could totally pull one over on everybody, but I'm not that kind of person. When the 64-bit Windows project was getting off the ground, the original target of 64-bit Windows was the Itanium processor, which I saw a news article recently that Linux finally dropped support for the Itanium, like 15 years after Intel stopped making them.
Right.
And I'm sure all 50 people who still own Itaniums are very sad. But at the time, Intel still believed in Itanium, and it was their first 64-bit processor, and the Windows was being ported to it, and the kernel was finally ported enough that you could boot to a command prompt. And they said, "This is great. We can now boot Windows to a command prompt. It would be really nice if the GUI worked." So they asked me and a couple other people to go off and port the shell to 64-bit code. So we sat down and spent, I don't know, a few weeks, something like that, just doing this massive porting thousands of files, trying to get them to build, see all the compiler errors, fix all the compiler errors, and eventually it's oh, we finally have a binary, and we put it on a machine and see if it runs. And the story of Pinball was that, yes, I successfully got Pinball to build and run 64-bit. However, you couldn't play the game because when you hit the plunger to launch the ball would come into the chute and then just fall out the bottom of the table because something went wrong with the collision detection. So the ball would just pass through all the walls. It would pass through the plunger. It would just fall out the bottom of the table. And we didn't have time to like go through and actually like debug why collision detection was not working. We still had another, 90,000 files to port, or however many files it is. Like we still hadn't done solitaire. Like we still have to port solitaire. I can't spend all my time on pinball. So okay, maybe pinball was more important, but we just made the decision. It's like, okay, our goal is to port as much as we can. And if we spend 4 days trying to figure out why pinball is not working, that's going to cut into a lot of our time budget. So we just set pinball aside and ported as much as we could. And we never had time to get back to pinball. So we just made the executive decision right there is that, well, the Itanium's target is high-end server systems. You probably aren't going to be playing pinball on the server in your data center. So if we took pinball out of the project, like the intended target audience wouldn't really care. In fact, they would probably be thankful that pinball wasn't on the machine, because it meant that you spent $40,000 on this big honking machine, and you don't want the people in the data center playing pinball all day on it. So we just made the call. It's like, okay, we'll just take pinball out of the product. And so that's why pinball, as far as I knew, was not in Windows 64-bit edition. But then some enterprising people found like beta copies and other things and found that pinball was back. And so then they're like, hey, you lied to me. Pinball's back. What happened? And the answer is, I don't know what happened. When I left the story, it was like that when I left it. Pinball was not in the product when I handed the port of the shell. Like we got Explorer and everything all working. When I handed the port of Explorer back to the 64-bit team, and I didn't hear back from it's like presumably somebody figured out what was wrong with pinball. And looking at some of the research that other people have done, I'm thinking it was a floating point rounding issue. So it could be that there was like a problem in the C runtimes that they found where floating point rounding was not working quite right, because the Alpha AXP did have a more complicated floating point system than the Intel math coprocessor. Like the Intel math coprocessor has an 80-bit intermediate floating point, which can mask a whole bunch of calculation errors, because you're calculating you're extending your intermediate calculations from 64-bit to 80-bit. So this gives you a little more precision or accuracy, one of those words. Gives you more stuff, gives you more mantissa. But the Alpha, I think the Alpha had like 3 different floating point formats. And you had to like pick it. It's like, oh, am I going to use floating point F or G or something? And I guess the way the math worked out, just some of the rounding went the wrong way and collision didn't work. But I guess...
Did it work equally across all the CPUs, or was it particular CPUs had an issue? Like, was it Intel versus AXP versus Itanium, or was it all 64-bit?
It's interesting. So we only had 2 64-bit processors available. One was the Itanium, and at the time, we didn't even have physical Itanium hardware. It ran only in simulation. So you could turn on your Itanium simulator and boot Windows, and a couple hours later, it might finish booting. And so this was not practical. Like, You can't play pinball on a machine that runs at 0.1% of full speed. And so what we did was we took all of our old Alpha AXPs, because Microsoft had already retired Alpha AXP as a Windows target. But there were still all these Alpha AXPs still, sitting in developers' offices, like doing nothing. And so they're like, hey guys, we found something to do with your Alpha AXPs. And so the kernel team actually ported Windows to the Alpha AXP and said, guess what? We have Windows running on a 64-bit processor. It's not the one we plan on shipping with, but that one's not ready yet. So why don't we port to this guy first? And the expectation was that most of the porting problems were independent of the specific CPU it was, that most of the porting problems would just be in getting any 64-bit version working at all.
Okay.
And so all of our actual testing and validation at this stage was done on Alpha AXP because that was the only 64-bit processor that actually existed. So yes, we had this collision detection problem on Alpha AXP. We had no idea if we had this collision problem on Itaniums because Itaniums didn't exist. The physical hardware didn't exist yet.
Okay.
But my guess is that other testing, maybe like running some mathematical tests or something, they identified some sort of rounding problem and fixed it in the C runtimes, and then that magically made Pinball work again. That's my guess as to what happened. It could be that somebody sat down and spent a weekend trying to figure out what was wrong with Pinball. It's like this person really, really wanted Pinball to work on his data center machine. I do not know what happened, but at any rate, somehow Pinball started working again, and they put it back in the product. This happened without my knowing. So when I told the story, Pinball wasn't there when I handed 64-bit Windows back to the kernel team.
Okay. You once got a death threat over Xcopy, I recall.
Oh my goodness! So yes, I received a death threat. There was a person who wrote in to product support, very upset about the Xcopy program. I don't even remember what it was.
System or hidden files, I think, being copied properly, if I remember.
Oh, they were upset about how it handled system and hidden files.
Yeah.
This person was not having a good day, was very upset, and included in the message saying, if I find out who did this, I will kill them. And so technically, since I was the person who did this, technically, I guess that would mean that I did receive a death threat. As far as I know, there has been no attempt to follow through on it.
Well, that's because the switch did actually exist in Xcopy, I believe. He just wasn't aware of it. So you escaped with your life just on
that's
the
right.
merits
I
of having
escaped with my life because the switch did in fact exist. He just didn't know about it.
There you go.
So that's right. That was my way of begging for my life. It was like, the switch is there. Trust me, it's in there. Just try it.
So when, and where, and how did your path take you to Microsoft originally?
It was senior year of college, and I had already sent out my applications for graduate school. I was a math student, and I hadn't heard anything back, so I was getting kind of nervous. I'm like, oh, wow, if I don't get into grad school, I should probably get a job. What's all that about? I had always considered myself an academic, and it's like, oh, I should probably get a backup plan and get a job somehow. And so I went to the career center and looked at who was interviewing. It just so happened Microsoft was interviewing that week. And I'm like, yeah, I can probably pull off one of these. So I signed up and I came in, and the interviewer asked me to reverse engineer some super optimized 8086 assembly language, which was, for me, just a fun little puzzle. It's like, hey, how do you take the absolute value of a number in 4 instructions, right? So, but it was
new at the time, for sure.
Yeah, this was cutting edge at the time. And so, it'd be like, hey, here's a little snippet of assembly language. Tell me what it does. And I'd work it out. It's like, oh, that's really cool. This is calculating the max of 2 numbers without any branches. That's awesome. And apparently they were satisfied with that enough to call me out for an summer internship interview. And apparently I passed because they brought me in.
So you were an intern first then?
So I was an intern. In the meantime, my graduate school application, I got answers back, and I actually got into one of them. So it's like, okay, I will do a summer internship for a year and then go to graduate school. So I did a summer internship at Microsoft. That was in '89. And I worked on, believe it or not, the MS-DOS emulation layer in OS/2 2.0. So MS-DOS emulation is clearly something I've been working on for a very, very long time. And I did the extended memory driver for OS/2 2.0's DOS emulation layer. And then after the summer was over, I went back to school. And then the next summer, I was like, I kind of like working during the summer. That was pretty neat. So I came back to Microsoft again. They were happy to have me. And the second summer, I worked on OS/2 1.3 printing, which was not an enjoyable project. And so I sort of decided that I would not work on printing anymore. So I haven't worked on printing anymore. While I was in college during the summer, I did database programming for a very small company. And that's also why I haven't done any database programming. So I've already realized what types of projects I like and what I don't. And I stay away from printing and databases. So if you have a question for me about printing or databases, I'm going to skip it and go on to the next one.
How do I print my database?
How do you print your database? You go and ask somebody who cares.
So you're wearing a tie. I seem to remember Make Raymond Wear Normal Clothes Day. Do you remember that? I wasn't on your team at the time. I was in the NT Shell team, but I remember some of the details. Can you tell me about that?
Yeah, so my shtick at work was that I actually wore a jacket and tie to work, and this was a holdover from my high school days. I went to a school that had a jacket and tie dress code.
Okay.
And so I is like, oh, you have a job now. You should like dress like grown-ups do. And the only grown-up clothes I had were jackets and ties. So in a way, I wore jackets and ties more out of necessity because it was the only clothes I had. But it turned into a thing. Everybody, like, I was known as the guy who wore a jacket and tie to work every day. And as a joke, or maybe as a prank, or as a jokey prank, or a pranky joke. As a sort of joke, prank thing, the members of the team said, hey, what would it take to get Raymond to not wear a jacket and tie to work? And when, so there's like, everybody's like trying to come up with their ideas. And when I heard about this, I said, I decided to say, okay, here's the deal. I will wear normal clothes to work if everybody else wears a jacket and tie. And for some reason, people thought this was cool and actually wore a jacket and tie to work. And I turned it into a fundraiser for my high school. So I said, everybody who participates, I will donate $10. For each person who participates, I will donate $10 to my high school. So my high school still has me on their donor list because they got a good amount of money out of it.
Good. But you made him wear shoes and a tie and a jacket, right?
Yeah. Oh, yeah. We made it clear in the rules that it's like Raymond will wear normal clothes, and in exchange, you'll need to wear a suit. But by suit, we mean like business suit or like school uniform type suit. No birthday suits, no swimsuits. Like we it's like understand the spirit in which the exercise is undertaken. And nobody tried to push the rules. I think we did have one person come in military dress, which I thought was pretty interesting.
Yeah, especially if they're entitled, if they're...
This wasn't cosplay. Like he really had it. And it's like, yeah, you're probably like dressed smarter than everybody else here. Like you kind of win. It wasn't a competition, but you kind of won with that.
So there was a time there when our offices were like 2 doors apart. And I remember if I would get stuck on something, I would always be very tempted to, let's just go ask Raymond. Because I know Raymond knows, but I don't want to just be lazy and just ask Raymond all the time. So it was always nice to know you were there. Who does Raymond ask? Does it really depend on the area of domain expertise, or are there people?
Yeah, I guess one advantage of having been at Microsoft for a long time is I have a lot of names in my Rolodex.
Right.
And so if I run into a problem and it's like, oh, I'm running into a problem with networking, it's like, I have friends on the networking team and I can just like ring them up. And so it's not like there's one person I go to, but I know a lot of people around the company. Most of them owe me favors, and so I get to cash in a favor once in a while.
Any good registry stories? Why do we call it a hive?
So the developer who implemented the registry code found out that another developer on the team really didn't like bees. Like I don't know if he like was like scared of them, or he like aggressively disliked them, or he just thought they were too smug, or something, but he didn't like bees. And so the developer who was writing the registry code decided to needle his colleague by naming all of the data structures in the registry after things related to bees. And so registry keys are kept in units called cells, which are the little hexagonal things inside the hive. And the main registry file itself is called a hive. So he basically tried to jam as many bee-related terms into the registry code, specifically just to annoy his colleague who didn't like bees. So if you wonder now why a registry file is called a hive, it's because one of the lead developers of the I/O system didn't like bees.
UI question for you. As far as my wife is concerned, the correct answer to any dialogue that she's not 100% sure about is cancel in all cases. And I think a lot of users do that. Have you ever seen manifestations of that?
Like whenever faced with a confusing question, just try to find a way to not answer the question, which usually means like hit the X or try to cancel out. Like I remember we would one of the things that we would do in the development team is we would take time to go into the sit in with product support to understand how people are using Windows. And so during one of these product support listen-ins, I remember one person called in, was having some sort of problem, and the product support person was working with them on it. And the person said, "Is like, I have this problem," and it's like, "Yeah, well, we already identified this problem, but we should have made an update available to fix this. So when you turn on your computer, do you get a little message in the corner that says updates are available?" And they said, "Yeah, I think so. There's always this thing that shows up on my screen when I turn it on, but I don't understand it, so I just close it and make it go away." Your machines were not continuously connected to the internet. You had to dial in. And Windows is probably not going to sit there and it's like, "Oh, you're dialed in. Let me see if I can download a gigabyte of service updates." It's like, well, we'll try to take a little here, take a little there. Oh, wait, he's actually browsing. Let me back off, that type of thing. And so people were just not used to the idea of an operating system that updated itself. And so when this dialog came up saying, "Hey, there's an update available, click here to download it," they're like, I didn't ask for an update. What's all this? Go away. I'm trying to use my computer. And so this is just a general lesson that you learn from doing user interface work, is that when you display a dialogue to people, you want to try to get it so they will at least somewhat understand what it's about. But if any part of it is at all scary, they're just going to say no and try to get that thing to go away as fast as possible. This document contains macros. I don't care. If there's an option between yes and no, they're just going to say no. And so part of it is also you want to phrase your question so that way no is always the safe answer.
Right, exactly. Why was the time zone map so challenging in Windows 95? And why, if I pick Formosa, does it not highlight my home area?
The time zone map. So Windows 95 introduced the time zone map. This was you could go to the control panel, call up and pick your time zone just by clicking on the map. And that was really cool, and it was cute, and it would animate in, and it would highlight it, and everybody thought that was a lot of fun. Until geopolitics entered the picture. So the Windows team used the official United Nations recognized maps to determine where all the boundaries were. But of course, not all countries agree with the official maps published by the United Nations. In fact, there are boundary disputes all over the world. Even today, I think the United States probably still has a boundary dispute with Canada somewhere. Fortunately, there's no military aggression, but I remember there was the story about that island, but that was in dispute between Canada and Denmark, and but the conflict was just asserted by each country. Whenever they visited that island, they would plant their flag on the island and leave a bottle of alcohol, a bottle of whiskey or something on the island. And then when the other country came to visit, they would take down the other country's flag, put up there and replace it with their own alcohol. And so, even today we have these border disputes. But back then we were young and naive and thought it's like, everybody loves the United Nations. We'll just, if it's the United Nations says so, everybody must be happy. But of course, people were not happy. There was a border war in South America. I forget exactly which countries they were involved. And so, of course, the countries complained that, hey, you're giving these like 3 pixels to that other guy, and those pixels rightfully belong to us. One notable example of this is that there's a border dispute between India and Pakistan over a region that's along their border. And there's actually a law in India that says that if you produce a map whose boundaries do not match the official government borders, you have to put a stamp on it that says this map is incorrect. Now, the Windows 95 time zone picker did not bear the stamp that said this border is incorrect. And there really was no facility for putting a stamp on a bunch of pixels on your screen. It's like, well, we could put a stamp on your monitor, but then your monitor's got a sticker on it or something. And in addition to these border wars, there were even arguments from countries who were not engaged in a border conflict, where like a small European country would contact us and say, hey, can you, like, our country is kind of small. Can you give us one of our neighbors' pixels to make it easier to click on? Because our citizens are having trouble clicking on that thing because we have to hit a really tiny target. And then the other country we'd get a response from the other country saying, or from some country saying, hey, why did you give one of our pixels to our neighbor? Like, if you look at the map, that pixel belongs to us. Like, and it's like there was no military conflict here, but they were just like, out of nationalistic pride, is like that pixel is more than 50%, our country's. Like, it should be ours. Like, why won't you give us our pixel? And it's basically impossible to satisfy everybody on all of these things. And so we just made the decision. It's like, you know what? We will rotate the map to put your country or your time zone like in the center. So it looks like, hey, there you are right in the middle, but we're not going to highlight anything. So nobody can complain. It's like, oh, you gave too many pixels to our neighbor over there. It's like, I want that pixel. It's like, well, nobody gets any pixels. There was a bug that we introduced when we did that, though, because the way the time zone map works is that we had a map of the world, and it was color coded. We assigned a color to every time zone. And the idea was that, if you picked, United States Pacific time, we would say, oh, okay, that's green. And so we would find all the green pixels on the map and highlight them. And then all the other pixels on the map, we dim them. And so we just use the color coding as a way to identify pixels on the map. But what we showed to the user only showed either either a bright green or dark green for highlighted or not highlighted. And so we just took out all the coloring code, but the map was still there. It is just that we still used the map to identify where land and ocean was. Now, the problem was that at some point, Poland, there were some changes to the time zone information for Poland. And as a result, Poland sort of merged with its neighbors and agreed to use like Central European time or Eastern. So there was some common time zone that a bunch of these countries decided to use together. And as a result, Poland's time zone was assigned to match those of its neighbors, but we forgot to update the colors in the map. And so as a result, Poland's time zone, the original like exclusive to Poland time zone, disappeared.
Okay.
Because nobody was using it anymore. And as a result, when you went to the world map, the time zone picker map, there was ocean where Poland is supposed to be, because we went through all the code. We went through all the time zones. Like, oh, every time there's a time zone, it's like, great, color him green because he's not ocean anymore. But since the originally, the original time zone assigned to Poland was just deleted from the list because nobody used it. We forgot that the map used it. And so Poland never, you can think of it as like every time we saw a time zone, we like raised it out of the ocean and gave it dry land. And Poland just like stayed at the bottom of the ocean.
Lake Poland.
Yeah. So I forget exactly when we finally fixed it, but there's a period of time where if you went to the time zone map, instead of Poland, you saw what we called the Great Polish Sea.
Why has taskbar grouping been like the major focus of computer science for 20 years, it seems, and they haven't figured it out? ChatGPT figured it out. What's the right way to group taskbar buttons?
The right way to group taskbar buttons is actually a complicated problem.
Right.
Because, like, it's obvious to a human being looking at things. It's like, oh, yeah, well, those two things are clearly different. And those two things are clearly the same. But the taskbar doesn't see things that way. The taskbar sees like names of running programs. It's like, oh, this program created a window. I will remember, oh, these windows all came from the same program. But then you have other types of programs that sort of act as frameworks for other programs to run inside. For example, Python. Like, if the taskbar relied only on the executable, then all your Python programs would all get jammed together because they're all running python.exe.
Right.
But you, the human being looking at it, well, clearly that's not, because this is my Python program for, doing the game of life, and this is my Python program that I use to chunk some database. And so, the human being says, well, these programs are clearly not related. Why are you grouping them? It's like, well, because they're both Python. It's like, well, don't do that anymore. And it's like, okay, I have to come up with some rule for deciding when I should decide that two Pythons are the same and when they aren't. And so there are these rules. They're written. They're in the documentation. If you're a program like Python, so, you don't want all of your Pythons to be grouped together because logically, you're not really the program that the user's thinking about. The user's thinking about the script that the Python program is running. Then you should do these things to your windows to get them broken up separately. And then there's the reverse problem where there's like a group of programs that all work together, like a productivity suite, where like, oh, here's Word and here's the Word equation editor, and they are actually two different programs. But you want them to group together because to the end user is like, no, it's Word and the Word equation editor. Clearly, they are the same program. It's like, but if you look at the executable names, it's like, no, one's Word.exe and one is EQED or something like that. And so now you also have to, in addition to taking programs that match on the executable and artificially splitting them apart, you also have to do work to identify programs that look like they belong together and artificially glue them together. And so again, there's documentation on how you can like write your program and like do things to help the taskbar identify which things really belong together and which things really should be kept separate. And it's hard. Like maybe we can just make ChatGPT do it.
Right. That's
right. It's like, hey, now that we have this thing, it's like, hey, you just like look at these windows. Like here's a screenshot. Here are all the windows. Like you tell me how they should be grouped. And
20 seconds later, you'll have your
answer. Well, 20 seconds later, you'll have your answer, and it'll be 80% correct.
Right, there you go.
And then you'll wonder why, hey, these two things grouped okay yesterday, but today they're separate. Like, what's going on? It's like, well, ChatGPT decided that they, random number generator decided they were different today.
You wrote a book a number of years ago, The Old New Thing. Great book. I'll link to it in the video description and recommend people check it out. One of the stories you have in there relates to vending machine user interface design and how the prices and the selection items should be designed so it doesn't cause confusion. And it seemed really non-obvious. I mean, it's obvious once you know it. Can you tell that story? Do you remember that one?
Oh yeah, this was when I was like learning about what do they call it nowadays? HCI, human computer interaction, but basically just like how to design things so the user interface is less annoying. And so one of the problems that I saw when I was in college. When you're in college, you spend a lot of time getting snacks from vending machines. And one of the things I noticed in the vending machine was that there would be a snack that cost like $1.45. And so you put in your money, and then you type in, because it costs $1.45. That's the number you're thinking of. So you punch in $1.45. But the machine doesn't want you to punch in the price. The machine wants you to punch in the code of the item you're buying. And so you would accidentally buy item 145, which would be like some candy bar that you're allergic to. And he's like, oh, rats, I bought that. I meant to buy item number 157 because that's the actual item code number. But I just, out of absent-mindedness, I punched in the price because that's the number I was thinking of.
Especially the days of two-digit pricing when you could buy things for 45 cents. It was even more confusing, I'm sure.
That's right, because usually what they did is they just numbered everything from like 11, 12, 13,
Right.
and then 21, 22, 23, all the way out. So when you got something like a stick of gum or a pack of gum for 45 cents, and then you would punch in 45, but then you wouldn't get the pack of gum, you would get whatever was in row 4, column 5.
Right.
And so my fantastic realization was that you just should make sure your item numbers don't match the prices of the items, because this is a mistake that people make. Nowadays, they solve this problem in other ways, like they'll have the items use letters instead of numbers. So if you type in the price, nothing happens, because it's like, no, there's no item called 145. You want to type like E7 or something.
Right.
So at least they figured that out. It's like, okay, we make sure that the price of something never matches the code of something, because people often, when you're in a hurry, you're hungry, right? You're not thinking straight. You'll just like punch in whatever number occurs to you.
What do you remember of Bunny, Bear, and Piglet from the Windows team?
Bunny, Bear, and Piglet were 3 little stuffed animal mascots that the team had. Bear is the oldest one. Bear was the mascot for, I believe it was Windows 3.1. Bear was just a little stuffed animal, stuffed little teddy bear, that was carried around by one of the development managers, dev leads. He carried it around sort of like a security blanket, like a kid would carry a stuffed animal. And but of course, this was the day where people expected software developers to be somewhat eccentric, and so everybody just like, yeah, there's Dave. He carries a stuffed animal around. What are you gonna do? Not you, Dave. Different Dave.
I once walked in and I was holding my stuffed orca, and he had his stuffed orca, and we met in the hallway by mistake. So
it's the meeting of the stuffed animals.
It was.
But of course, one of the things that you do when one of your developers carries a stuffed animal around is, of course, you steal said stuffed animal and hide it, and then cause the other Dave to say, has anybody seen Bear? And then there would be you'd leave a clue. It's like, getting colder, and this was all in fun. Dave seemed to be okay with the joking around. He was semi complicit in the joshing. So it was not mean spirited. It was all in this spirit of the exercise. So Bear was the mascot for, I can't remember if it was Windows 3.0 or 3.1. If you go and find the either 3.0 or 3.1 Easter egg, it will show a list of credits, and it will also show an image. And I believe one of the images that cycle through is a little stuffed animal teddy bear. So that was Bear, and I believe Bear is even credited as Bear in the Easter egg. So that was Bear. Bear was the mascot for one of the Windows 3 point somethings. And one of the ways that Bear manifested itself in the product was that all of the internal functions that were used to communicate between the window manager and the graphics system and the kernel tended to be named Bear and then a number. To tell people, is like, this is just an internal function, like don't call it. But we knew that, like, oh yeah, the function that takes a device context and returns you a region that tells you which pixels are visible on screen right now, that's Bear 23. So if you're going through the code and there would be a header file with a macro saying pound define and give it a decent name, but then it maps to bear23. And so if you were reading the source code looked normal. But then if you looked at the final output, the name of the function in the DLL would be like bear23. And so the idea here was just to tell people, it's like, you're not meant to call this function. This is just for our internal purposes, and we can change it anytime we want. And so bear showed up and hung around as the name of internal functions in the system. In Windows 3.1, in Windows 95, Dave picked up a new stuffed animal called Bunny. And so it was just a little stuffed pink bunny. So now we had two stuffed animals we could steal from him and hide, which of course we did. And so Bunny sort of became the mascot of the user interface team. So most of their internal functions were called Bunny something something. Dave also bought a larger stuffed animal bunny, and so the smaller one was nicknamed 16-bit Bunny, and the larger one was nicknamed 32-bit Bunny, because Windows 95 was the transition operating system where we moved 16-bit, moved pieces of the operating system from 16-bit to 32-bit and added support for 32-bit applications while continuing to run the 16-bit applications. And so now we had three stuffed animals. We had Bear, who was semi-retired at this point. We had Bunny, and we had 16-bit Bunny, and we had 32-bit Bunny. Meanwhile, the kernel team sort of felt left out of all of this stuffed animal mayhem. And so one of the members of the kernel team, Mike, he had a stuffed animal Piglet from Winnie the Pooh. Just a little piglet sitting in his office. And so he decided that, I'm just going to decide Piglet's the the mascot of the kernel team. And so kernel functions, the internal kernel functions were named Piglet something something. So now you will see functions called Bunny and then a number, or Piglet and a number. And that also means that these are functions not meant to be used by applications, but are instead used by the operating system to accomplish its own internal tasks.
What was the USB cart of death, and how many people died?
The USB cart of death was, it did not kill any people, but it did kill a lot of builds. So when USB was first being developed, of course, the kernel team, the USB team is put together, and they're like frantically writing code to support this new hardware device and protocol and all these other things. And the USB cart of death was one of those like office carts, like a mail cart, but it was loaded with like every USB device that they could get their hands on. So it had like a USB mouse, USB keyboard. In fact, we'll have like 3 USB mice and 4 USB keyboards, and maybe a USB connected printer and some USB everything, and they were all connected together on this office cart, connected through, of course, a whole bunch of USB hubs, set to the maximum. So I think at the time USB had a limit. The USB limit was 64 devices. So it's like, okay, let's go get 64 things and like put them on this cart, plug them into. And it's like, and the USB spec says, you can daisy chain hubs up to 3 deep. It's like, okay, we're gonna daisy chain hubs up to 3 deep. It was nicknamed the USB cart of death because it was just this cart loaded with crazy USB devices. In order to help maneuver this cart, one of the USB devices was a USB gaming steering wheel, which was attached to the front, so you could actually drive this cart down the hallway. And it was called, and the way you used the USB cart of death was you walked up, you drove up using the steering wheel. You drove up to the office of a developer on the kernel team who was working on USB. And you said, "Hi, do you have a test machine? Yeah. Can I plug something into it?" And they'd be like, maybe. And you plug, and everything funneled into just one plug. So you plug that one plug into the test machine. The entire USB infrastructure would go crazy because it's just like, oh my goodness, I see 64 new machines connected through hubs 3 deep and all this other stuff. And depending on how you felt, if you were the person driving the cart, you might just like sit and wait for the entire USB system to settle down, and then like try typing on the keyboard, see if the keyboard works, play with the mouse, see if the steering wheel works in some game. If you were feeling rude, what you would do is you would plug it in, watch the plug and play system enumerate the devices and start loading drivers for them, and then yank the plug right in the middle. And then watch the USB system frantically recover from devices disappearing while it was in the middle of installing them. And so this was the card of death because the usual result of this was a blue screen.
Right.
Because, all this code was just like fresh out of the oven. And so this thing found like race conditions and all sorts of, unhandled error conditions. And you could just walk into a lab, like the USB testing lab, just have a whole row of machines and just use this one thing, the USB card of death. Plug in, yank it at a, count to 5, yank it. Move on to the next machine, plug it in, count to 7, yank it. Move on to the next machine, count to 7 again, yank it. Oh, crashed in a different way. How about that? And so you could just have every morning an entire bank of machines that have all crashed, waiting for developers, ready for developers to come in and debug and figure out what went wrong so that way it wouldn't crash next time. And it wouldn't crash next time the same way. They'd say, yes, we fixed that bug, and that's great. Let me do it. I yank it. Yes, congratulations. It crashed for a different reason. And eventually the goal was to get it to a point where you could plug in the USB card of death, unplug it anytime you wanted, and everything would still work. And I think they made it.
Eventually, yeah. I remember it crashed during the Bill G keynote. Chris Capossela was on stage with Bill, and they were doing a scanner into Win95, and I think it blue screened under the USB stack.
I believe that was showing USB support in Windows 98.
Oh, really? Okay.
Yeah, and so that
it was a beta either way. I know.
Yeah, and that predated the card of death. The card of death may have been inspired by it. Maybe it was like, we want to make sure this doesn't happen again.
Do you have any examples of people using features in ways that were not intended?
Yeah, so one of the things we learned when porting from 32-bit Windows to 64-bit Windows, doing all the porting, was that data is like weeds. Like, if there is a place you can hide data, some data will hide there. So, for example, here's we have some storage for you to store a window handle. You're supposed to store a window handle here. But people are like, really? I'm supposed to put a window handle here? What if I just put a 32-bit pointer in there? It's like, as long as I promise never to actually call the thing that uses it as if it were a window handle, you won't even notice that I put something that wasn't a window handle there. And so people just find ways of like hiding data in places that were never intended to hold that kind of data. And so when we were doing our port from 32-bit to 64-bit, we would say, oh, here's a 32-bit value. That's great. It's supposed to be a window handle. Good. Put a window handle in there. And then we'd run some program and it would crash because they're like, yes, it's big enough to hold a window handle, but since I never call any of the functions that need the window handle, I'm going to put a pointer in there. And then later on, and since I'm 32-bit code, that 32-bit pointer fits in the 32-bit data. And then later on, I'm going to pull out that data, say, hey, can you give me my window handle? And the system is like, yeah, here's your 32-bit window handle. And we're like, thanks. And then cast it to a pointer and then use it as a pointer again. And this works as long as your pointer is the same size as a window handle. But if you found, so maybe window handle was a bad example because window handles also grew to 64 bits. But if it was just like a 32-bit integer, you jam a pointer into a 32-bit integer. When you port to 64-bit code, that's now a 64-bit pointer. It doesn't fit into a 32-bit integer. Parts of it get lopped off. You read the value out, you cast it back to an integer, you try to use it, and you crash. And so there were a lot of places where we had to go in and say, okay, here's a place where it was supposed to be a small integer, probably no more than 100. But people learned that, well, I could put any 32-bit number in here. I'm going to put a pointer. And so we're like, okay, this is now a 64-bit integer, not expected to be more than 100. for those of you who like to put things in here that were not small integers. And so that's just one of the things I learned is that if there's a way to abuse storage, it will be abused.
A few weeks ago, I had Dave Cutler here. Did you ever work with Dave or meet him at Microsoft?
I never met Dave Cutler, but I did receive one very angry email from him once, which I guess for most people is the maximum interaction you want with Dave Cutler. In fact, maybe the wish is if you're lucky, you never have to interact with Dave Cutler, at least not when he's sending you an angry email. It was in response to a blog post that I wrote talking about NTFS compression. And I mentioned that the compression algorithm had to be scaled back in order to accommodate some weaknesses in the alpha AXP instruction set. And he wrote me a very angry letter saying that this is absolutely not true and I should have my journalism license revoked. And I didn't want to tell him that I didn't have a journalism license. And so I subsequently issued a retraction on that article. The information, I guess the way you would describe this is what my information was poorly sourced. That's my excuse. My apologies to Dave Cutler. He apparently is a better source.
Did you ever run into Bill Gates?
I have actually never met Bill Gates. The closest I got to meeting Bill Gates was when he was making the rounds of our team, and selected people were given. He's basically everybody. We were going to put on a little dog and pony show where he would walk around to people's offices and casually drop in on them and ask them what they were doing. But of course, everybody knew that he was coming and would have a whole presentation prepared for him. But the conceit was that he was just doing a little walk around and just checking on things. And so one of my colleagues was chosen to be one of the people that Bill just casually dropped in on. So he had a demo all lined up and ready, and he had like a little script for himself, so he knew what steps to go through on the demo. And Bill comes in, says, hi, come on in, have a seat. And Bill sits down, and he inadvertently sits down on the sheet of paper that my colleague had written down all of his notes on how to run the demo. And at that point, he just sort of like quietly panicked inside and tried to run the demo as best he could from memory. And he didn't lose his job, so I guess the demo went off well enough. So I guess the answer is don't leave your important cheat sheet somewhere that the boss can sit on it.
There you go. Did you have anything to do with Windows Power Toys? Do you know the origin of the Power Toys?
The Windows Power Toys, they come out in the Windows 95 era. They were originally, so there was this period of time after Windows 95 was released to manufacturing. So this is when back when this was a thing, we had an official CD. And it's like through some ceremony, we delivered this CD to our manufacturing facility. And there's a big party. And at that point, you can't make any more changes to the product because they're going to be like stamping out billions of copies of it, putting them in boxes and everything. And so what was left for the team to do at this point, the testers on the team were going crazy. It's like, okay, we have like 3 months before the machine hits the retail floor. And so the test team was going nuts, just like running every test that they could, just running them over and over again, making sure that there were no like killer bugs lurking in the product that would force a recall. The development team, on the other hand, had plenty of time on their hands because it's like, I can't write code. If I write, it's too late to write code. Right. It's already done. And so we played a lot of Doom. Of course, every so often, one of the testers would find something, a test would fail, and they'd be like, there's something went wrong with this test. It's like, can you look at it? It's like, oh, okay, fine, hang on. Sorry, guys, I got to drop out of this multiplayer game. Got to go look at a bug. Okay, fine. And then you'd look at it and you might say, it's like, oh, yeah, that's a real bug. We'll have to write a knowledge base article to advise users on how to work around it because there's no way we can actually fix it. Like the CDs are already being manufactured. So the best we can do is to document it, and provide information so that way the product support people, when people call in with this problem, they can type in the symptoms and the article will come up and they'll walk people through fixing it. But one of the other things when you got tired of playing video games was you would just like write fun little programs. And so the Power Toys emerged, the original set of Power Toys emerged from the development team themselves, who just like wrote fun little things. Some of them were actually written during the development of Windows 95 as a way of like validating that the architecture worked. So some of them were like shell extensions. And so I was like, well, in order to validate that our shell extension architecture works, we should write some shell extensions.
Right.
And so I was like, oh, I'll write a shell extension for controlling your CD player. Or I'm going to write a shell extension for like doing a way to copy files to another folder quickly or something. And so everybody just, came up with these cute little things. And we just gathered them together, put them in a box, called it the Windows Power Toys, and sent them out. And one of the toys was mine, which I called TweakUI, which was just a little program that gave you access to some additional settings that were not included in the control panel. So, things like controlling how quickly the menu or how long the menu lingers after your mouse moves out of it, or how quickly the menu opens after your mouse moves into it. Because if you're naive and you make the window dismiss the moment the mouse leaves and open the moment the mouse enters, using the mouse turns into one of those mouse dexterity games that you find on the internet where it's like, hey, I built a maze. Use your mouse to move the dot through the maze. And if you touch a wall, you die. And if you don't add these little delays to your mouse interface, then trying to click on an item on the menu turns into one of these little maze games because you have to move straight up, and then move straight to the right, and then move exactly perfectly straight down. Otherwise, the menu is going to dismiss and you get mad. Anyway, so there were some settings for controlling some of these delays and various other attributes of the system, but there was no interface for them in the control panel. And so TweakUI was just my cute little program. It was like, hey, here's some extra settings that you can control too. And somehow TweakUI like turned into its own like mini cottage industry. Like it developed like 12 tabs and like 5 million settings.
Is it still around? Is it still produced?
We'll get there.
Okay.
So sometimes teams would actually come to me and say, so we've got some requests from customers to be able to control the setting because and there's a way to do it. Like there's a knowledge base article that says how to do it, but it's really frustrating because a lot of them are not, all that technically inclined. So could you just add another tab, like tab number 14 to TweakUI for these extra settings? So that way, when a customer calls in and says, hey, I need to do this thing, we say, oh yeah, just download this program, go to tab 14, there's a setting for it. So TweakUI sort of became a product support tool.
Okay.
But on the other hand, it became the anti-product support tool. I think Windows 98 included TweakUI in the bonus content on the CD. But in like future releases, it was taken out because what would happen was people would find it in the bonus content of the CD and they'd run it. And it's like, whoa, this is really cool. And they'd just like go nuts checking stuff. And then their system would like start acting really weird.
Right.
Because they just went off and just checked random stuff. And then they wonder, it's like, hey, my mouse doesn't work anymore. It's like, well, yeah, because you set the mouse sensitivity to 20 million. And so product support actually asked us to take it off the CD because they were getting a large number of calls from people with some problem. And after working with them to solve it, they realized that, they ran TweakUI, went berserk, forgot about it, and now they have this problem. And so TweakUI disappeared from the CD and went back to a download-only thing, with the theory being that if it's an explicit download, you have to have made a conscious effort to get it.
Right.
And therefore, and so it puts some barrier to entry. Like your low confidence user is not going to go download this thing from a Microsoft website and run it. Like they're happy they know how to go to a Microsoft website. So it sort of created a small but meaningful barrier to entry to messing up your machine. The Power Toys then spun off a separate family of tools called the Kernel Toys, which were a much lower level set of tools for managing things like configuring your conventional memory. These are all very Windows 95-y things that nobody cares about anymore. Or doing collecting some timing information on how your system is booting. And I think there was a time zone editor that was put in there too. And the secret story of the Kernel Toys is that I basically wrote all of them. Like they were all just my little kernel things, and I just packaged them together and say, here you go. I guess we can put this thing up for download too. And I wrote the weird blurb that talked about all the kernel. It's like, oh, here are the Kernel Toys that do these things. And my proudest moment with the Kernel Toys was the joke in the Kernel Toys README that said, please don't expect to see very, very polished UI because these people do their taxes in hexadecimal. The Power Toys finally stopped being published. I forget exactly. I think it was like Windows XP era was still around, and then it sort of faded out. Part of it was due to a general company policy that by policy, we no longer make things available for download that are unsupported. Like that's sort of, and that's a reasonable policy. It's like, why would we make something available for download and then not support it? If it's not supported, we just shouldn't have it.
Right.
And so the Power Toys were one of the casualties of that.
Okay.
However, the name Power Toys returned. Clint Rutkus sort of recycled the name Power Toys, and there is, if you search for Windows Power Toys, they're back. It's an open source project now. It's in a GitHub repo, and it's not mine anymore. Like Clint and his pals, like they go off and they write all sorts of cool stuff. It sort of serves a similar purpose. Like a lot of the things in there are tools that developers themselves wrote and thought were useful enough to share with others. Like Fancy Zones was written by one of my colleagues because he has a very large monitor, and he wrote this thing to help him position Windows on his very large monitor. And the Power Toys people were like, wow, that's really cool. Can we ship it? And he's like, yeah, sure. Here you go. I did contribute one Power Toy or one tool to the Power Toys, which is the Find My Mouse tool. This is a thing where if you're running it and you tap the control key twice, a spotlight zooms in on wherever your mouse is, so you can move it around. Because as monitors get bigger, it becomes harder and harder to find where your mouse is. Because it's like, okay, you look at your monitor over here, you wiggle your mouse like crazy, and you don't see anything because it's on that part of the screen way over there. And so if a spotlight zooms in on it, that sort of draws your attention. So it's like that meme thing where it's like, nobody move a muscle. It tracks things based on movement.
Right. So back in the days of AppCompat and Windows 95, tell me about the big trip to Egghead.
Ah, yes, the big trip to Egghead. So the development manager for the overall Windows 95 project, he was a very clever man who often took unconventional approaches to problem solving. And for the app compatibility, for the issue of like, okay, we need to make sure that Windows 95 has maximum compatibility with existing Windows 3.1 apps. So he took his pickup truck, drove down to the local Egghead, which, if you don't know, Egghead was a store that sold computer software. Those things actually existed. Like it was an actual store. You walked into it and there were rows of shelves of software on it. I'm pretty sure none of those stores really exist anymore. They're like now the corner of like an office supply store or something. But at the time, there were actual businesses completely dedicated to selling boxes of software. So he drove his pickup truck down to the Egghead, walked into the store, and said, I would like one of everything. And they're like, what are you talking about? It's like, I would like to buy one copy of every PC software product that you have on your shelves. And they're like, really? It's like, yes. It's like, okay. And he just loaded up his pickup truck with one box from every product in the store. I'm sure this completely, completely messed up all of their ordering from that store. First of all, that store was probably very, very happy because they hit their quotas for like 3 years in one day. And, well, maybe not 3 years. But they did a really good job. But it probably also messed up all the predictive ordering. He's like, oh, you sell this much last month? Let me go reorder like twice as much for next month.
Right.
But he returned, that is like, not my problem, that's Egghead's problem. He returns to the Microsoft offices with his pickup loaded with software, unloads all the software onto tables in the cafeteria, and calls everybody in, calls in the entire dev team, the developers, testers, everybody, and says, I just bought one piece of software, one of everything from Egghead. Every product is represented here. You can go in and pick a piece of software and adopt it. It is yours. The expectation is that you will install it, test it, file bugs. If you do a good job, you can keep it. And so all of a sudden it became like a flea market. Like everybody was just walking up and down the aisle. It's just like, oh, what did you get? It's like, oh, did you find anything good? I'm still looking. And you come out with your piece of software, take it back to your office, and you install it, run it, file bugs against it. Games were, of course, a very popular genre, and most games at that time were DOS-based games. They were not Windows-based games. And so me, MS-DOS compatibility guy, bugs ended up mostly landing on my plate. And so I spent a very large chunk of my time in the Windows 95 project doing application compatibility for games. And some of them were really interesting. There was one game I remember, there was a bug that only manifested after you'd been playing the game to level 27. It was one of the wing commanders, I believe. Because when you finally get it to level 27, you get a cloaking device. And the bug was, play the game until level 27, until you get the cloaking device. Start a mission, press the key to activate the cloaking device. The result is no cloaking device. So you can't pass the mission because you need that cloaking device to pass the mission. Fortunately, he included a save game because there was no way I was going to play that thing for 40 hours to get to level 27. And I figured it out. The problem was that the hotkey for the cloaking device was Control-C. And so that conflicted with the existing code in the MS-DOS emulation layer that treated Control-C as a cancel key for if you pasted a large amount of text. So if you had a large amount of text in the clipboard and you hit paste, we would manually simulate keyboard activity to type all those letters into the keyboard. And if you hit Control-C, we would stop. And the problem was that the Control-C that you hit was being interpreted as a stop pasting text, and the app never got to see it.
Right, so it got eaten.
It got eaten. And so I was like, yep, this is a real bug. So I added some stuff. And so now it's like, oh, we will only honor that hotkey if a paste is active. Because while it was the case, it used to be when you hit the key, we would recognize it. We would say, oh, I'm sorry, paste is not active. We didn't actually eat the key. What we did is we replayed the key back into the app. So we would say, okay, control key down, C up, control key up. The problem is that our replay was too fast. So we would replay the key, but the app would not check the keyboard fast enough. And so we'd never see the key get pressed, right? We'd say key down. He would say, is the key down? No. And then we would press the key and release it. And he would say, how about now? No. And so it would never actually see the cloaking command being activated. And so, yeah. And so the solution was just completely ignore the hotkey sequence if a paste is not active. So then the key went in at human speeds and then the app could see it. Race conditions were a very common source of problems because when you're running in a multitasking operating system, the app is no longer getting 100% of the CPU. And so it's like, yeah, I learned that I can do exactly 500 of these things a second. And well, but now if you're multitasking with Excel, you can only do 250 of them a second. And then maybe in a couple of minutes, you can only do 100 of them a second. And so you would often get into apps that ran into trouble because things weren't happening at the speed that they were expecting. They were happening too fast or too slow. Like in this case, a keyboard sequence, we would replay a key sequence too fast and it wouldn't see it. Sometimes we would, like if an app was not getting enough CPU time, we'd be like, oh, I'm so sorry, you didn't get enough CPU time. Here, we'll give you some CPU time to let you catch up. 3 timer ticks happened and you missed them. So I'm going to give you 3 timer ticks in a row. Bang, bang, bang. And it would happen too quickly because he always thought in between timer ticks, I can always get a frame out because a timer tick runs at like, whatever it is, 57 milliseconds. And I need to get a frame out every 16 milliseconds. So clearly I can get like 2 frames out. So, but if we just push 2 timer ticks in, bang, bang, then he couldn't get a frame out, divide by 0 somewhere, or something terrible would happen.
Is there a particular piece of code or feature you look back on now that gives you immense satisfaction that you've written in the past in particular?
There's a couple of things that I'm proud of, although not necessarily because they were complicated. Like the one feature that I was most proud of for a long time was that I fixed Pinball. It's always Pinball. I fixed Pinball so it didn't consume 100% CPU. So
I wanted 1,000 frames per second.
Yeah, so it was often the case is like, oh, you kick off a build, you got some time to kill, I'll play a little pinball. When the build is done, then I can go and continue and do my development work. But the problem was that Pinball was written for Windows 95. It ran at 100%, it pegged a core, it ran 100% CPU because back in the day, like if you ran Windows 95 as fast as possible on the processors of the day, it could just about keep up its frame rate. But in the meantime, processors got faster and faster. And so I went to figure out like, okay, why is it taking so much CPU? And I realized that it had no frame rate limiter. It just rendered frames as fast as it could. And for fun, I found that there was some debug code to print the frame rate in the upper right-hand corner of the screen. So I turned it on, rebuilt it, ran it. It just showed asterisks. And that's because it only included a 2 or 3 digit field for the frame rate. But the actual frame rate, now the computers had gotten so much faster, was like, it was generating like 1 million frames a second. And so it clearly didn't fit. And my solution was, oh, I'll just add a frame rate limiter. I will just say, you know what? If you're at 100 frames a second, I think that's good enough. You can take a break. Take a break, come back when it's time for another frame in another 10 milliseconds. And once I added a frame rate limiter of 100 frames a second, the CPU usage just plummeted to like 1% or something. And so that for me, that was my proudest moment in Windows development was I fixed Pinball so you could kick off a build and play pinball at the same time. In terms of, now mind you, that was not very technically difficult, but it gave me great satisfaction. Something that I am more proud of from a technical standpoint is that there's a debugger called the time travel debugger. This is a debugger that what you do is you run your program under the time travel debugger, and it captures a trace of your program. So it records every single instruction that your program executes. If you execute a read instruction, it remembers what memory was read. If you execute a write instruction, it says, okay, good job. That's the memory that was written. And when it makes this recording of what your program did, you can then load the recording back into the debugger and replay it. And the great thing about this is, since it is completely reproducing what happened last time, when you're doing normal debugging, sometimes you'll be like, okay, I'm going to set a breakpoint. You do some debugging. It's like, I messed up. What do you have to do? You have to start the program over, try to get back, get to the original conditions, set the breakpoint again, try to debug it again. And often, getting the program into the state where you want to debug it takes far more time than the actual debugging you want to do. But with time travel debugging, it's already recorded. So you can just say, go to time point so-and-so in the recording. And then you can just start your debugging from there. And if something went wrong, you're like, okay, it's a recording. So you can just say, execute backwards, go backwards in time, reverse, step backwards. And okay, I'm going to step forwards again and pay closer attention to something. So it's a really fantastic tool for debugging these types of problems where setting up the problem takes a really long time.
Right.
Often the problem might be like, I found a memory corruption. I found the code that's corrupting the memory. Who freed this pointer? And you can't set a breakpoint ahead of time. You don't even know where this breakpoint for the bad free is. But if you have a recording, you can go, hit the point where it's like, here's where we use the bad pointer, and then execute backwards to look to see who freed that pointer, right? So you have like the benefit of clairvoyance or hindsight, depending on how you're looking at it. Anyway, that's a very long setup for the fact that one of the things I made some contributions to the time travel debugging code. And one of the things I did was, in the code that does the replay is actually done by jitting the simulation, the simulated instructions that were previously executed. You can even make a recording on an ARM and replay it on an x64 machine, because we can replay ARM instructions. Like basically, there's like a tiny little ARM emulator inside the time travel debugger that's like single stepping in ARM, but it's really not single stepping in ARM. The great thing is time travel debugging is actually done in microcode. When you execute an ARM instruction, it actually breaks it down into like 3 little microcode instructions and records those microcode instructions. And so then the replay happens. And so I did a little work in the jitter that takes those microcode instructions and regenerates x64 code to execute those microcode instructions. And I wrote a couple of the jitters for some of the microcode instructions, but I also wrote the register allocator for the jitter, and I was very, very proud of that. So that was a very long story to say, I wrote a register allocator for a jitter. I'm so happy.
I'd be happy too. Back in the old days, one time, I colored compressed files blue and encrypted files green. I still argue that's a good idea when it's not the only indication. Of course, explain why it's actually a bad idea and what they're doing with it now, because I think they've taken that feature away.
Yeah, so there was a time when compressed files were blue. Was it compressed blue and encrypted green?
Yeah.
The problem with that, of course, is that there are people who have different types of color blindness, where those colors like are not distinguishable. And so this is one of the things you always have to pay attention to when you're doing user interface work that involves colors. You have to be conscious of the fact that there are people who have visual processing, or their problems with color processing in the eye. Either it doesn't pick up on it, or the brain has trouble processing the colors. And so you can't have color be the sole indicator of any particular piece of information. And so I actually don't know what we do now to indicate that a file is encrypted or compressed. I think we just don't indicate anything. But if you go to the properties, it'll be listed as whether it's compressed or encrypted. Fortunately, we don't have the problem of trying to show something in 2 colors at once because a file cannot be both compressed and encrypted.
Right.
Otherwise, we would have to figure out how to do a checkerboard pattern
Or aqua.
or aqua.
Green and blue
That's
mixed.
right. And now there's like, oh, another category of color blindness can no longer use our product.
All right, I got a question in 3 parts.
Oh,
Number 1, have you ever watched a usability test where they bring in subjects to test out and try features? Number 2, if so, did it trigger rage, sadness, or both? And number 3, what would be the German word for both at the same time?
yes, I have observed usability studies. This is the setup that we had the subject who was in a room with a computer, and of course, there's a camera recording them, and we are in the room next door that can see in, but they can't see us because it's a one-way glass. And we would ask them to perform what we thought was a simple task, and of course, the user would struggle with it.
Install the printer driver. Yeah.
I think actually one of the tasks we asked them was, here's a document, print it. And they had managed to open the document in Word or WordPad or something, whatever the program was. And they were looking at the toolbar. It's like, okay, one of these must be print for printing. This was back when toolbars were the cool UI thing. It's like, hey, we put a toolbar in. We'll see if that helps people find how to print things. So they found the toolbar. We're like, yes, toolbar is working. They're looking at the toolbar. And they look at it and they're like, no. They mouse to the picture of the printer. The mouse lingers on it for like 2 seconds and they say, no. And then they keep moving. And like, no, boldface, no. And like were right there. It was a picture of a printer. Didn't occur to them that was how you print. And so watching this game or watching a usability study to me is like being an audience member at a game show where there's the contestant up on stage and they have to like guess the price of something. And you're like saying, higher, higher, higher. No, stop. And you're like screaming at them, trying to get them because you know the answer and they don't. And the usability researcher actually had to tell us to keep it down. It's like, they can still hear you. Can you like not yell at them? And so it is a combination of, what was it? Frustration.
Rage and sadness I had.
Frustration, rage, and sadness. The German word for that, I do not know. Currently my favorite German word, however, is verschlimmbessern, which is a combination of the verb verschlimmern, which means to make worse, and verbessern, which means to make better. And so verschlimmbessern is to make something worse in a well-intentioned but misguided attempt to make it better.
There, I fixed it. Yes.
Yes, it's the there I fixed it.
There is a perception that 16-bit Windows is really just a shell running on top of MS-DOS. Can you explain why that's not the case and what makes 16-bit Windows a real operating system?
Actually, it is.
Well, Windows 286 and 386, once you're kicked into protected mode, that was something
Yeah,
DOS
but that's
never
not
did.
what we were talking about.
Oh, that's what I was talking about. I'm sorry.
Right. Yeah, so I can't remember. I think it was Windows 2.0 that added support for the 386.
I think so.
It was Windows, that added enhanced mode. And so what happened was there are actually 2 operating systems running. The Windows 386, which was the internal name for this component, was running a 32-bit operating system. It was a 32-bit multitasking operating system with multiple virtual machines. And inside one of the virtual machines was a copy of 16-bit Windows. And so 16-bit Windows was like running as a program in a virtual machine. And the other virtual machines were used to run your MS-DOS programs. And so you were really running like 3 operating systems at once. There was the Win386, the virtual machine manager, which was managing all the virtual machines, providing virtual services like simulated keyboards, simulated timers, negotiating who had access to the video card, that sort of thing. And then inside one of the virtual machines was a copy of Windows, the GUI Windows, and then inside the other virtual machines was running a copy of MS-DOS. And so you actually were running 3 operating systems all at once, and with the virtual machine manager like being the main one that's sort of negotiating who gets access to what. But even in that case, with Windows 95, Windows 95 took it even further. It started, I think, in Windows 3.11 with Windows for Workgroups, where the file system was taken out of 16-bit code and was written in as a 32-bit device driver. So when a program running in the virtual machine, either 16-bit Windows or MS-DOS program, accessed the disk, the disk I/O operation, the file I/O operation was trapped and handled it up in 32-bit mode, and all of the file system code ran in 32-bit mode, and then the results were given back to you was returned to the original application, which meant that, like, even though you started your computer running MS-DOS, and then you ran Windows, the Windows you ran actually first ran Win386, which sort of put the original copy of MS-DOS to sleep, just took over the operations from it, and then ran Windows and MS-DOS sessions. And so the original copy of MS-DOS was like not really running anymore. It was just lying around. And so you really didn't have MS-DOS running the show anymore, although everybody thought it did because that's what booted the system. But really, right, MS-DOS was just being used as a bootloader.
Tell that story.
We should actually remember you did the thing about the Janet Jackson. You did your own experiment on it, and then did you see the video that Adam Neely put out about?
Was that the musical guy?
Yeah.
Yeah, he did a really nice job on that.
He did a really. He even found a paper that like looked for like what is the resonant frequency of a hard drive. I'm like, hey, it's right there. That was cool.
Yeah, he took it one step further. It was really cool. Mm-hmm. In the Win32 window manager, there is a mouse enter leave, or there is a mouse leave, but there's no mouse enter.
Yeah, where's mouse enter?
Yeah, why do you only have one? What's up with that? How would you ever possibly know?
How would you know? Well, because the mouse move message acts as a mouse enter, because when the mouse moves over your window, you get a mouse move message. And so you can just keep track. The first mouse move message you get after a mouse leave must have been a mouse enter.
Right. So you set a flag.
It's a sneaky trick.
What about long file names? Any heartache come from those when they were first introduced? Doing compatibility with the short file names and the tombstones and having files come back. It seems like there must have been a fair bit of...
I do remember one of the decisions that was made when we were designing long file names was that the long file names would be stored in Unicode. And this was a controversial decision at the time because Unicode is like, dude, that's like going to take up twice as much space as regular characters. Like, that's going to waste so much disk space. But the engineers who designed it is like, trust me, you're gonna be happy you had Unicode. And it turns out, yeah, that was a good call.
Yeah, I remember with the shell IDLEs, I was doing the MIPS porting, and I realized that IDLEs can be an arbitrary number of bytes long because you can have an ANSI string in there. So if you've got a 17-byte string, your next ID list is not 32-bit aligned. So I was trying to make the case for at least let's 32-bit align PIDLs or 16-bit aligned text or something, but every instruction that touches anything within an IDLE is wrapped inside of a try except now to watch for. Or it was at one time, I should say.
Yeah, so IDLEs, we're talking shop here. IDLEs, ID lists, this is
it's like a path, but for the shell.
Yeah, it's the way that items in this shell are represented. And it is a binary format, variable length, just like PAS. And so, yes, there was no requirement that each IDLE component was an even number of bytes. And so in practice, they could be any size. And yeah, this caused problems on basically every processor that wasn't an x86.
Exactly, yeah.
Because RISC processors were, in the days, not very friendly to misaligned memory accesses. And in particular, trying to load misaligned memory was... Like even if you knew ahead of time that the memory was misaligned, loading a value from an address that is misaligned takes a lot more work than loading memory from an aligned address. So
Yeah, I think loading a 32-bit word is pull a byte, shift, pull a byte, or pull a byte word in. You have to build up a 32.
like depending on the processor, some of them had like there was one that had like load left, load right, where you could say, hey, here's a misaligned address. Could you just like load the part that you can into this part, into whatever part matches? And so it would, in the easy case, there were some processors where it would only double the number of instructions it took to load a misaligned word. But then there were processors like the Alpha AXP where it took like 8 instructions to load a misaligned word. And if you guessed wrong and you thought the pointer was aligned, but it turns out it was misaligned, depending on the processor, it might take a fault, which is going to cost you like 1 billion instructions, because now you trap into the kernel. The kernel goes in and says, oh, I see what you're trying to do. Okay, let me do those 8 instructions for you and then resume. But you really should have done those 8 instructions yourself, because now you're paying a kernel trap and everything. So it ended up costing you thousands of instructions. Or if you were really unlucky, the processor would just say, look, you were supposed to pass aligned addresses, so I'm just going to ignore the bottom 2 bits of the address and assume it was aligned. And you're just like, congratulations, you loaded a value from the wrong address. And so, yeah, misaligned data is very unfriendly to RISC processors. Nowadays, it's gotten a little better. A lot of them nowadays can handle misaligned addresses. They fix it up internally within the chip, so the cost is not so bad. But still, you probably shouldn't rely on it.
This is just a random question, but if you have a PC and you've got 2 video cards and you've got 2 mice and 2 keyboards, is there any way to split it into 2 workstations? It's, other than setting up VMs and passing through video cards to each VM, which you could do. Any way to have 2 Windows stations on a single PC yet?
I don't think so.
It's probably not a common request, but I'm just curious.
Yeah, well, it doesn't work because the input system has a single input queue, and so it can't segregate the input knows which keyboard it came from,
right?
But they still get processed centrally, and most of the time, like the information about which keyboard it came from is kept with the key press, but nobody cares unless you use like the special raw input API, which does let you query which keyboard produced this key. But no apps care about it. And the window manager itself doesn't use it for routing.
Okay.
So sorry, it didn't help. There were also the game developers who thanked me for going insane.
Did you go insane?
Maybe. So when the stories went around of all the work that I had done to get video games working in Windows 95, some developers, video game developers, who were visiting Microsoft because this other project called DirectX was getting off the ground, and so they were coming in, and we were having a little meeting talking about DirectX and what features they need from DirectX, that sort of thing. And they heard the story about some developer on the Windows 95 team who got all of their games working in Windows 95, but at a tremendous cost because he went insane. And I received a letter from them containing this email message that said there's this developer who got all your games to work but went insane. And it was a printed out letter from the developers, and it just had a handwritten message at the end that said, "Thanks for going insane," with their signatures. And I have it. I have that letter framed. It's packed up in a box somewhere. I have to go find it.
Legend holds that you have an unused VIP ticket to the Win 95 launch event.
Yeah, so for the Windows 95 launch event, if you go back and watch the videos, fast forward over all the Jay Leno stuff, at the end of the launch event, they drop the curtain and the entire product team is up there in the bleachers cheering. And the plan was to put the product team up there in the bleachers, but there were a few seats available in the tent to watch the launch as an attendee. And so there was just a lottery within the team, and a couple of people were randomly selected. It's like, congratulations, you get a ticket to the tent. And I happened to be one of the people who was lucky enough to get one of these tickets. So I had a ticket to the Windows 95 launch. But one of my colleagues really wanted to go into the tent and see the show. And so I said, fine. So I gave her my ticket. But then at the Windows 95 launch, while all of the team, we were, being herded and gathered and prepped to go up onto the bleachers and do our cheering, I saw that she was in the room with us. And I said, what happened? I thought you had a ticket. And she said, yeah. And she handed the ticket back to me and said, but it didn't feel right. I realized that this is being with the rest of the team is where I really need to be. And so I have an unused ticket to the Windows 95 launch. I do not know how many of these tickets still exist. I know there is at least one because the Microsoft Museum has a copy of an unused Windows 95 launch ticket, although it's not clear to me whether that was a ticket that was issued but never used or just a spare ticket that they saved for archival purposes. Meanwhile, I learned that I was talking to some colleagues who worked on the Windows NT printing team at the time of the Windows 95 launch. Specifically, they worked on printing on like very, very high-end printing. Like really nice printing. Not your like $100 desk printer, but like professional grade printing. So they had access to really good printers. They also were able to like catch glimpses or sneak pictures or otherwise learn what the different tickets to the Windows 95 launch all looked like. They created forgeries of the Windows 95 ticket. They used that to get inside. They would walk around. They would see like the staff. They would notice it's like, oh, it's a badge. Like get a quick look at it. Make a fake badge. Run back to the office, make a fake badge. Now they have this fake badge. They had fakes of like every single badge they could find. They would like come in and they noticed that it's like somebody's, they would like overhear somebody trying to get into the, trying to get in, and it's like, oh, I misplaced my ticket. So it's like, okay, well, let me look for your name on the list, blah, blah, blah. And they learn this like, oh, some people have like a little yellow star sticker on their ID card. And it's like, what does that star sticker do? Oh, it means that they have access to this other like after party event or something. It's like, yellow stickers, get yellow stickers. So they were basically doing one of these like Mission Impossible type things where they were just doing massive recon, finding out what could get you maximum access to every part of the event, and then very quickly manufacturing forgeries of every single pass. So by the end of the day, they had successfully produced forgeries of every single pass they could find. I do not know how many of the events they actually attended. I think part of it was just the challenge of
the fun's in making the passes. Tell me about the confidential coffee maker.
So back in the day, Microsoft and IBM were working together on this product known as OS2. Maybe you heard of it. But, Microsoft, based in Redmond, the IBM offices that were doing OS2 work were in Boca Raton, Florida. And so there was always there was a small contingent of Microsoft employees who were sent down to stay in Boca and sort of act as liaisons between the work happening in Boca and the work happening up in Redmond. The rules the rules for how this arrangement was done was that Microsoft employees, that these people would be rotated through. Like nobody would be stuck in Boca for the whole time. You would go down for a few months and then you'd be sent back home and then somebody else would take your place. The problem, immediately there was a problem because there was a significant culture clash between the Microsoft way of doing things and the IBM way of doing things. The IBM way of doing things was very corporate. You had to, there was a dress code. The Microsoft way of doing things was, are you wearing pants? Good job. And so, for example, the security regulations down in IBM were much stricter. You would get written up. You would receive a citation if somebody saw, for example, you would get a security violation if you beeped yourself into the building and somebody snuck in behind you, right? That's a security violation. Unauthorized person enters the building. You would get a security violation if you left papers on your desk at the end of the day and didn't put them away in a locked cabinet. Because, well, it's okay, fine. Visible documents not in a secure location. You would get a security violation if you wore shorts. I'm not quite sure how wearing shorts is a security violation, but nevertheless, that's how they classified it. The rumor was that there were many rumors that circulated regarding these security violations. One rumor was that if you received 6 violations, then you would be kicked out and be sent back to Redmond. However, somebody reported that this rumor was not true. They know this rumor was not true because they tried it and it didn't work. There were other rumors about if the total number of violations amassed by all Microsoft employees reached a certain level, then a certain penalty would be imposed. Nobody really understood what actually happened. What actually happened to all of these security violations? Was there just some big box with a huge stack of papers that things just kept going into? Nobody knew. But one of the other things that caused trouble was that Microsoft people from Seattle like coffee. In the Boca Raton offices, there was a vending machine. You could put money in that vending machine, and in exchange, it gave you an undrinkable brown liquid, labeled coffee. The Microsoft employees were not happy with that sort of undrinkable brown liquid, and so they brought their own coffee maker to work. This was immediately cited as a security violation because it was an unauthorized heat-generating appliance. Now, there was part of the agreement between Microsoft and IBM that anything labeled Microsoft Confidential was off limits, and IBM could not open any box or any envelope labeled Microsoft Confidential. So the Microsoft employees who liked their coffee got a cardboard box, cut a door in it large enough to fit a cup of coffee, and put the box over the coffee machine and wrote Microsoft Confidential on it. This successfully prevented them from receiving any further security violations for their confidential coffee maker because IBM, by agreement, were not allowed to look inside.
Yeah, they were able to wear shorts with impunity. I've heard that. Tell me the Steve B. rental car story.
As you might expect, Steve Ballmer, who was head of the operating systems division at the time, would occasionally go down to Boca Raton to sync with his IBM counterparts. There was one time he went down and for some reason, I'm going to make up a story. It's like, hey, we'll have dinner together. So he, goes to dinner with a bunch of the other executives. And it's like, oh, it's running late. We'll just take you straight to the airport. So Steve goes straight to the airport, flies home to Redmond. Everything is great. Except that he left his rental car in the IBM parking lot. There was another employee at IBM who was sort of proud of the fact that he was the first guy into work every day. But now he would come into the parking lot and there was this other car there. And he's like, who is this other employee who is like really diligent and beating me into work every day?
And staying late too.
And that car, when I leave, he's still there. Like, this guy is crazy. He's like working harder than me. I thought I was the hardest working guy at IBM. But in fact, it was not an employee. it was the rental car that Steve B had left in the parking lot. And when the story of the mysterious, hardworking employee got around, Steve realized, is like, oh, wait, that was my rental car. And presumably had the issue addressed with and had a very large car rental bill to deal with.
I once lost my rental car keys on the beach.
Ooh,
And
that's rough.
It was. We were having a barbecue or a fire pit out on the beach, and I got lost. And we searched for hours. Couldn't find them. And I had like an hour and a half to get to my airport at this point with a family. And I called Amex, and I told them, and they were like, okay, we're going to send a tow truck to come tow the car, and we're going to send a van to come pick you up your family, and they'll be there in 30 minutes. I'm like, okay, Amex. So I was really impressed. But
It's a story that Dave has already told, which is you left your phone number in the
that's
code.
true, yeah.
Like there was a time, like under a particular set of conditions, which I think was like certain numbers didn't add together properly.
If
like, there a
CPU
math
was
error.
greater than 100, basically.
Oh, if CPU was greater than 100. And it would break into the debugger with a message saying, if you see this message, call Dave PL, and it had your phone number. And it hit. And we're like, should we call Dave? I don't know. I think we decided not to call you.
I've had one call.
You got one call?
Hit. You actually were out of
I think it actually hit once.
Yeah, it turned out to be a kernel accounting bug, and I had to prove that it wasn't.
That wasn't you.
Yeah, and the onus of proof is pretty high when you're a new app versus the kernels.
I was math guy, but I was also like computer hacker guy. Yeah. So it's like I cut my teeth on the Apple II Plus, and like learned assembly language on that thing, disassembling ROMs, patching stuff. Is like I reverse engineered. Like my dad, he bought a hard drive. Now, this doesn't sound exciting today. In 1985, buying a hard drive was a big deal. That thing was like this big, and it held like 100 floppies. It had storage capacity equivalent to 100 floppies, had its own power supply and everything. But the drivers for that hard drive only worked with Apple DOS 3.3 and CP/M. But Apple had a new operating system called ProDOS. And it's like, oh, how am I going to get this to work? So I actually spent way too much time reverse engineering that driver enough so that I could get it to boot into ProDOS. That's right. And UCSD Pascal was the other. It supported 3 operating systems: Apple DOS, UCSD Pascal, CP/M, and I added ProDOS. I still don't know how I managed to pull that off.
6502.
But it was like a lot of 6502 assembly that you're just like staring at and trying to figure out. Which was particularly because the 6502 only has 64K of address space. And so in order to get all of their firmware code mapped in, it was bank switched. And so it's like, okay, you capture this bank, and it's like, oh, but then you turn around, look back, it's like, the bytes are all different. It's like, yeah, somebody bank switched it to something else. So I never really understood enough of it, but I somehow managed to cobble together enough to get it to actually boot into an operating system that they never intended to support. So then so clearly I've developed my hardcore reverse engineering hacker skills, which meant that it's like, oh, first of all, it's like, dude, you're comfortable in assembly language. That's really great. So it's like, oh, okay. I got myself an 86 assembly language book, teach yourself assembly language, IBM PC assembly language. It's like, great. I learned that now I know IBM PC assembly language. I'm writing stuff in assembly language because it's fun and because BASIC is really slow. And probably those were good enough skills to get me an interview, and I had enough just general experience
And you enjoyed your time working on software as an intern enough that it led you to a different path, or was it more glacial or slower than that? Or did you know after your internship?
Oh yeah. After the internship, I was like, this is more fun than math.
Right.
But I did get a full scholarship to get a math PhD, so I should at least give it a shot. So So I went back, did the math thing, and then it's like, okay, that internship was kind of fun. I'm gonna do another summer internship, even though my scholarship would have paid for me to stay there all through the summer. So I actually probably lost money coming to work for Microsoft for the summer,
Right.
because a lot of the money you get paid, but then a bunch of your money goes back towards housing, and so the amount of money you actually take home was probably less than I would have made just from my stipend.
Right.
But I enjoyed it a lot more. And then I realized, like, I'm just going to do this. Like, this math thing is not working. So it was like I started hitting a wall in math. It turns out math is hard. You may not have noticed this, but math is kind of hard, or at least. And so I had enough aptitude to get through undergraduate math and early graduate math, and then I hit my wall.
I hit that in grade 9.
So I hit my wall. I'm like, I think I've maxed out at math. It's just not moving forward anymore. But it's like, hey, I got this other thing. So I called Ben Slivka, who was my my boss when I was an intern.
I didn't know that. He was mine too.
Yeah.
That's why I came and worked for him as an intern.
Yeah, and I said, hey, can I interview for a job? And he's like, sure. And so he set me up a loop. I showed up, and the loop was much more relaxed than the internship loop because they already, like, my reputation preceded me. They're like, yeah, just get this guy. So like the interview loop was less like, should we hire this guy? But rather, let's try to convince this guy to quit graduate school and come to work here.
I didn't have that feeling. I did really good as an intern, and I kind of thought, well, I'm a shoo-in to come back as an employee because I had such a good internship. But then the 5 people you're interviewing with 6 months later, that's nice what you did 6 months ago, but
what can you do for me now?
Yeah. And they're different people. It's not the same team. So everybody, was quite fresh, I think. What part of this job keeps you coming back?
Yeah.
The health insurance?
You'd still be debugging things on Cobra. So.
Yeah. I don't know. I mean, it's something to do. I mean, part of it is like, I noticed like when my dad retired, and he got bored.
Yeah, I did too.
And so it's like, well, it gives me something to do. It sets a good example for my kids because my kids aren't like, they're not out of college. Like they're still in high school and, middle school. It's like, we need to set the example. It's like, in order to be a productive member of society, you need to get a job, contribute, make the world a better place. And not like, oh, dad retired early and he sits and plays video games all day. That's what I should do.
Right. I remember asking Mark Z about that a long time ago. Like, why do you still working? And he's because I've got little kids and they need to see me go to work every day.
I need to set a good example for my kids.
Yeah.
What did your father do?
My dad was a college professor. He taught mechanical engineering, specializing in heat transfer. It was like during.
Maybe he could have helped with that coffee machine at IBM.
Well, he would have told them what they needed to do to keep that thing from burning up the table. Like when I was in college and I'd come home for Christmas break, and I would grade my dad's students' papers, his exams. He was like, okay, here's the problem. Like he would basically like in 5 minutes teach me what it took him a semester to teach the other students, because he only had to teach me enough to be able to grade the problem. It's like, okay. It's like, oh, we set up this problem. This is the formula to use. Give them 10 points if they know which formula to use. Give them 3 points for doing the math right. Take a point off if they drop a sign. That sort of thing. But then I would look at the problems, and and it's like, okay, some of these students are like, they're like following the cookbook but not understanding the cookbook.
Right.
And so it would be like there would be a problem like we're in a room. The room is 20 degrees C. There is a pipe carrying hot water that goes across the room, and the water is entering at like 90 C. What temperature is the water when it gets to the other end of the pipe? Assuming certain,
flow rate,
insulation characteristics, whatever. And some of the students would come up with answers like, oh, the water temperature is negative 20 degrees. I was like, how can the water freeze
Well, the formula
on its way across the room?
Well, it's because it boils in the middle and then it gets colder outside.
And then others would say, oh yeah, the water enters at 90, exits at 95. How can it get warmer? The room is only at 20. It's like, okay, you guys, you plug numbers in and you probably like dropped a sign or something, right? And it's like, oh, the answer says 98 degrees. Must be 98 degrees. It's like, look at the problem. Clearly, it cannot be 98 degrees. Physics tells you 98 degrees is not possible.
That was one style of interview question that I don't think they do anymore that I always thought was kind of interesting was the how many gas stations in America or how many of anything and getting somebody to estimate and be able to watch them, see if they're able to rule out their erroneous and crazy estimates and narrow it down to something useful.
Right. And it's like, and the final answer, there's still a very wide range of final guesses based on your assumptions. It's like, oh, let's assume like, there are average of this many people per family in the United States and every family owns 1.2 cars and, whatever, you do the math.
Yeah.
And, you're just pulling numbers out of your head. So your final answer is going to vary from the next person's. But the question is like, or did you just assume that like every family has 5 members? It's like, that might be kind of high. Every family has 12 cars. It's kind of high, or it's like you didn't even get to that point. Like you're just like, how many cars did I see today? Right? It's like, how did you arrive at the number of cars?
Yeah. When I left, I put all my cables in the center of the room because I went through all my drawers and desks and stuff is mine. I'm taking stuff is theirs. I'm leaving, and I had a massive pile of cables.
Yeah, I have to go through and just let go of some of these cables. It's like
I did it a couple of years ago. I spread everything on the floor and I kept, one of every SCSI, 50, SCSI, 68.
I don't need 3 of these.
Right, exactly.
And now it's like, I don't need any of these because if I need one, I can just go back to the admin and ask for one. It's like, I don't need an HDMI cable. The admin already has boxes of them. If I need one, I can just get one. And my spare time is like writing more content for the blog. That thing's still going.
You write quite a bit. Do you know how many words a week you write?
I don't know how many words I write, but I an article goes out every day, every weekday.
And you still don't have a journalism license.
No, I still don't have my journalism license. And so like, and I have a buffer. My buffer is now, I worked hard. I got my buffer back up to 6 months. So I have a 6 month.
No way.
Oh, really?
6 month lead of content. In my heyday, I had an 18-month lead. So it's like, and it was great because then it's like, I just like stop writing for a month, like, whatever, come back, it's like an 18-month padding. But it went down, it got down to like 4 months and then I just get really, really anxious. So
I've got no buffer. I've got nothing in the queue.
Nothing. Like
it's all going live tonight.
Like I can go on a vacation to Italy. I come back and my buffer's all gone. Well, I'm not going to go to Italy for that long, but I worked it back up to 6 months. So I'm like, okay, 6 months is like my minimum, that minimum. If it drops below 6, the anxiety really cranks up. But I want to try to push it up, try to get it to like 7, 8 months, just 9 months. 9 would be great. This is like very strange. Most people don't have that much front loaded content.
No, they certainly don't.
But it's like TV shows where they're like, yeah, we're filming this week for an episode that's going out 2 weeks from now.
What comes to mind as the most challenging backwards compatibility thing you had to fix for Win95? Is there anything that stands out?
Well, I remember there are a whole bunch of just really bad things that programs did. A very common thing that games did was when they started up, they just tried to allocate all the memory they could. Just keep allocating memory until it fails. And this works if you're running an MS-DOS where you're not competing against anybody else. And there's no virtual memory. So it's like, if you're on a 4 megabyte machine, you just allocate memory. After 4 megabytes, it stops allocating. And you're like, okay, I guess I have 4 megabytes. But Windows 95 had virtual memory. And so what happened is initially when we started, doing the testing, you'd run these programs and the program would start up and then your hard drive would just start going crazy. And then the program finally finished whatever it was doing, and then it crashed. Because what was going on is it was allocating all the memory that it could. But since Windows 95 used virtual memory, it's like, oh, I ran out of physical memory, but I can just allocate more space on the hard drive, expand the page file, and get more hard drive space and just use that as memory. And so what the program was doing by allocating as much memory as it could, what it was really doing was allocating as much disk space as it could. So the first thing it did was it filled your disk. And then the second thing it did was it crashed because your disk was full. And it's like, oh, now let me save a file. I can't, there's no disk space. And so we added some stuff to say, oh, if a program tries to allocate memory, never give him more virtual memory than twice the physical memory of the machine. So at least on a 4 meg machine, it would get up to 8 meg, and it's like, okay, that's enough. But the thing that I think was the most useful in terms of accompat was there was a common problem in many categories of many categories of games. These were games that ran under DOS extenders. A DOS extender is a mini operating system whose job it is to provide 32-bit services to applications. And so what these DOS extenders did was, if you were running in MS-DOS, these DOS extenders said, oh, there's no operating system around providing 32-bit services, so I will do it. So it sort of became an operating system. But if a 32-bit operating system was already running, they would say, oh, there's somebody else providing 32-bit operating system services. I don't need to. Now, these programs were written on the assumption that the DOS extender that they were packaged with was the one running the show. And so they would rely on things like on various implementation details of their specific extender. And so when the program was running under Windows, their extender said, no, I'm not in charge. There's already an operating system here. I will let him do it. And so now this program is talking to an extender, namely Windows, that it was never intended to run against. One of the quirks of the virtualized x86 mode that the 8386 processor used and that Windows used to provide MS-DOS emulation, one of the quirks of it was that the pop flags instruction did not restore the interrupt flag. Now, Dave is nodding because he knows what that means. What it means, for those of you who don't spend your time staring at assembly code, is that one of the bits in the processor status register is called the interrupt enable bit. And if the bit is set, then hardware interrupts are allowed. And if the bit is clear, hardware interrupts are not allowed. It was common in these applications when they needed to do some critical code and they didn't want to be interrupted, was that they would save the current processor flags. So that would remember whatever the interrupt enable bit was, and then clear the interrupt enable bit. So now it's like, okay, hardware interrupts not allowed. Do their thing, and then pop the flags back into the processor to say, okay, restore the interrupt enable bit to what it was before I started doing weird things. And this didn't work in v86 mode due to a design decision in the chip. And so when you perform that pop instruction, interrupts still stayed disabled, even though they were enabled originally. As a result, when you ran these games under Windows 95, they hung the machine because they disabled interrupts and interrupts never came back and they never enabled them. So like your machine was dead. It wasn't me, but one of my colleagues came up with the idea that when we saw that an MS-DOS program was disabling interrupts, was performing the interrupt disable instruction, that is a privileged instruction, so we get to trap it and see that it happened. We looked around at the code nearby and saw, as like, oh, there was a push, and oh, there's a pop coming right after it. So I'm going to set the trace flag on the register in the flags that were pushed. The trace flag is popped back correctly. It is not ignored by the pop instruction. What the trace flag does is it allows execution to execute from one instruction and then raises a trace interrupt, which is trapped by the kernel. The kernel then sees the trace interrupt and says, oh, this is a trace interrupt that I manually requested when the application disabled interrupts. So I will say, aha, he finally popped the flags that contain the interrupting set. So now I will re-enable interrupts. So this was our sneaky trick to let that incorrect code sequence, maybe that's the wrong way of saying it, a code sequence that assumed it was running in raw MS-DOS, allowed that code sequence to work in Windows 95. And this allowed a large category of games to start working again once we added detection for these special interrupt sequences. The most important game, of course, in this category was Doom. Doom was the top game. It was taking over. It was taking the world by storm, and we were able to get Doom to run in an MS-DOS session under Windows 95, which was a tremendous success, because now we could run the most important game on the planet.
Thanks for joining me out here in the shop today. If you found the interview with Raymond to be any combination of entertaining or informative, please make sure you leave a like and that you're subscribed to the channel. If there's sufficient interest, I'll continue bringing you these interviews along with the regular content. In the meantime and in between time, hope to see you next time, right here in Dave's Garage. This little chair will be waiting for one of you, and a rocking chair for another who likes to rock, and a big armchair for two to curl up in. All next time on Dave's Garage.